The play begins. It's about a sort of Christianity or religion and physics, with a physics lecturer doing a lecture, at the end of which a Christian, a woman, comes up to him and says, "Can I ask you a question?" Having identified herself as a Christian, she said, "I want to ask you about quantum entanglement, and specifically about the fact that if you take a particle, call it an electron, and that particle is spinning in a particular direction. I know they don't spin as we understand it, but let's imagine at the point of measurement it's spinning in a particular direction, and you entangle that particle with another particle, B, it will spin in the opposite direction at the point of measurement. If you then separate, you'll know this, if you then separate particle B from particle A by 200 light years, which is the other part of the laboratory as far as the electron is concerned, and you reverse the spin on the particle you've kept, particle A, particle B will spin instantaneously in the opposite direction.
Right.
Even if it's 200 light years away. That's correct, isn't it? Einstein called it spooky action at a distance.
Yes.
So she says all that, and the lecturer says, yeah, that's right, talks a bit about it. Is that your question? And she says, no, my question is, if I'm to believe that, why shouldn't I believe in God? And then it's a play in which the mathematics and the probability of miracles get worked out by those two people.
Well, no, it's a very good point.
Well, no, the answer though is we've done the experiment.
We've done the experiments. No, but exactly. They think that taking it on faith because a billion scientists agree with it and write it down, and its peer group is the same as them going, well, I read it in the Bible.
But I would say, from my understanding of quantum mechanics, which will not be your understanding, is that it involves at times the nearest thing science has to faith. Because there are times when I've read stuff about quantum physics and I've thought, A, this is so mind-blowing, it's almost at the point at which I think, like, God, you'd have to...
There are two things here. One is, and Heisenberg thought about this way back right at the start of quantum mechanics. One thing is, all it is a theory of how particles move around and interact with each other. That's it. That's all it does. Even today, the quantum field theories, the most modern theories we have, that's it. And they're theories that allow you to make predictions.
Well, relativity was a theory that was then proved correct by experiment.
For example, the standard model of particle physics is a quantum theory. It predicted the existence of a Higgs particle, and we built the Large Hadron Collider, and we went and we found it.
Yeah.
So it makes predictions. So at one level, it's called the shut up and calculate school of quantum mechanics, where you do the sums, calculate, get a prediction, go and make a measurement, and everything we've ever done. So the way a transistor works, for example, is quantum mechanical, and it does work, and it works. But there is an issue with quantum mechanics in that if you want to interpret it, so you want to say, what is the theory telling me about the underlying reality that we live in, then it becomes very difficult, and we don't have an agreed upon interpretation. But you can just look at it as a load of maths that you can do to predict the outcome of an experiment, and it definitely works.